All right, number one, Bob gets paid $16 per hour, worked for the first 40 hours, and $24 per hour for each hour after the first 40. And actually, that's called time and a half. That's pretty typical. So working overtime, you get paid 50% more. So right now we're going to take the first 40 times 16, just do 16 times 40, and we're going to end up with $640 for that first 40 hours. And then he worked 55 hours, so 55 minus 40, he's going to have 15 overtime hours. So we do 15 times the 24, which is going to give us the 360. If we add up these two numbers, we should get $1,000. All right, number two, how many permutations? That means order matters. So permutations, it's all the different combinations, but order matters. Combinations is where it doesn't matter, right? But order matters here. So 1, 2, 3, 4, 5 have all odd digits adjacent and all even digits adjacent. And it gives us one example. So 5 and 1 are two odd numbers adjacent, and the 3. And then the 4 and the 2 are the two even numbers adjacent. So let's see if we can't come up with all of those options. Well, I'm going to list them out. We could use a formula, but we do have 6 minutes, and that other one went pretty fast, so it's okay if we write them out. So 5, 1, 3, and then the 4 and the 2, or 5, 1, 3, and then the 2 and the 4. But if we'll pause for a second, that 5, 1, 3, there's 3 different ways I could have a number there, 2 different ways I could have a number there, and 1 different way I could have a number there. So that's going to be a total of 6 ways I could have just this first combination, right? And then 6 ways I could have this combination with the 24 at the end. So there's 6 and 6. I'm already up to 12. Now if I take this 5, 1, 3 and put it in the middle, then I have a 2 and a 4. These are not adjacent, the even numbers, so that won't work. So the 5, 1, 3 has to be on the other side. And then the 4 and the 2 need to be next to each other, and then these are next to each other. So again, there's 3 times 2 times 1 ways to put these 5, 1, and 3 together. So that's a total of 6 ways if it starts with a 42. And then if it starts with a 24, there's a total of 6 ways to put the 5, the 1, the 3 together. 3 times 2 times 1. So that's going to be another 6 ways. So 6 plus 6 plus 6 plus 6. 6 times 4 is 24 permutations. All right, number 3, what is the sum of all the distinct? Distinct means unique, right? Distinct or different is a nice way to remember that. So different or unique values of the expression x minus y, z, where each x, y, and z is one of the numbers, -2, 5, -8, and none of them have the same value, so they're all unique numbers. So I'm going to start by plugging in, if x is -2, it's going to be minus, y could be 5 times -8. And here I have an odd number of negatives, an even number of negatives, which makes that a plus 40. -2 plus 40 is 38. And notice if I switch those, it doesn't change it. So -2, if I make it a minus a -8 times 5, I still get the same thing because there's an even number of negatives. So that makes it plus 40. So I get the same thing if I switch it. It's still going to be a 38. That's nice to keep in mind for later because that'll save us time. So far, the values I get are 38. I don't count it twice. And now if x was, let's say, the 5, then I would plug in a 5 for x minus yz. So the other two numbers are -2 and -8. and that's an odd number of negatives, which makes that a minus 16. So it's 5 minus 16, which is going to be a negative 11, right? And if I flip these, it doesn't change it, right? So commutative property, if I switch them around, it's still 16. So now I do my last one, which is if x is the negative 8, then y and z must be the other two. So negative 8 minus the negative 2 times the 5. And that's an even number of negatives, so plus 10. Negative 8 plus 10 is 2. And remember, if I switch these, it's still the same thing. So I just have those three unique values. So add these up, I get 40 minus 11 is 29, because I believe it does say the sum. So I just added up all these numbers. All right, number 4 at Southern Unified Middle School. Each student is taking algebra. I'm going to make a little Venn diagram here. So algebra, geometry, or both. Both is where they intersect, these two circles. The total enrollment is twice that of the geometry classes in algebra. And the number of students not taking geometry is 4 times the number not taking algebra. Okay, so the ones not taking algebra are going to be here. So if I call that x, not taking algebra, if I call that x, and 4 times not taking geometry, that would be over here in this section, right? So this section over here is the 4x. This section over here is the one without the algebra, is the x. And it says, what fraction of the students are taking both algebra and geometry? So I know that the number of algebra students is, if I double the number of geometry students, that equals the number of algebra students, because that was given in that first statement. Okay. Well, why don't I call this y where they both are? So if I add up 4x plus y, that's the number of algebra students. Because if I add up this whole circle here, it's 4x plus y. And then if I substitute in here for geometry, that geometry circle here is a y and an x, so it's 2 times x plus y. So I get 2x. If I distribute, that's 2x plus 2y. And then if I just subtract 2x and subtract 2x over here, I get 2x plus y equals 2y. If I subtract a y, I end up with 2x equals y. Well, that's super helpful, because right now I put in the middle that it's y, so this region is y. So what I'm going to do now is replace that with, that's going to be called 2x. Because now we're all in terms of the same variable, which is super helpful. So now we want to do the fraction that are taking both algebra and geometry. Both algebra and geometry. So both is going to be the 2x, so 2x over everything. So if I add up 4x plus 2x plus x, that's going to be 7x. And then the x's cancel, so it's just going to be 2/7.